Drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, as we are discussing the very important section of our session, that is preparation of hydrogen, where it can be prepared through water, acids and alkalis which contain hydrogen. So continuing with the subsection, that is preparation of hydrogen from water, wherein in the preceding video we learned how potassium helps in the liberation of hydrogen. So in these slides, we shall understand the preparation of hydrogen from sodium. So let's start with the session with sodium part. So before going through the reaction part, let's understand some basic properties of sodium. Friends, where we know that sodium is a metal and one of the group member of alkali metal, where if you see the modern periodic table, you can see sodium on the extreme left side of the modern periodic table with the group 1 and period 3rd with the symbol Na and atomic number 11. Looking towards the electronic configuration, it is 281. This means that one electron is present in the outermost shell of the sodium. This means, hence, it have only one single valence electron into its outermost shell. As it is a metal and you can say that it is a highly reactive metal, so it generates positive ion when it takes part in any chemical reaction. It have only single isotope. So moving towards the reaction with water, with any reactive metal, when chemically combined with cold water, it generates metal hydroxide and hydrogen gas is actually generated. For these kind of reaction, we have the separators, where we have a big beaker in which we have a cold water filled in it. We have inverted funnel with a metal gauges inside it. With over it, we have an inverted test tube where hydrogen gas is to be collected. So now, in case of sodium, when sodium reacts with water, gives out a sodium hydroxide and hydrogen gas is generated. Friends, though hydrogen is very reactive metal, just because of its one electron into the outermost shell, making it highly reactive and give the property to readily combine with other elements or compound readily. So you can see here, when a chunk of any alkali metal, let's this sodium, is put in the water, it causes an explosion because the metal dissolved generates an extreme amount of heat just due to the transfer of electron from sodium to water. But this reaction for the preparation of hydrogen is not preferred. Why? The first reason is that the reaction is very violent, but less than in the case of potassium. Secondly, sodium melts into globules and darts about freely onto the surface of water. Therefore, the collection of hydrogen becomes very difficult. And third, in this reaction, it gives a big explosion. So friends, please don't try it at home or try in the presence of your professor or teacher. So now let's understand why it happens like there's an explosion when it combines or reacts with water. So first, taking some basic points for sodium. Friends, sodium in its neutral position have 11 proton and 11 electron. Going towards its electronic configuration, there's one electron, it's present into its outermost shell. This electron makes the sodium highly reactive, and to make sodium stable, sodium has to go into its ionic position. That is when sodium gives out one electron. This one electron, it is converted into its positive ion, that is cation, and this is basically stable ion. So taking up this kind of basics, let's understand now what happens in this reaction. So friends, this is a beaker with the cold water. So when sodium is given into the water, what happens is there's a big explosion. Why? As a reaction is in fact a Coulombic explosion, as there's a rapid change or exchange, there's an electron exchange between sodium and water, causes the surface of the water with positive ions, which actually gives sodium a sodium octate stable ion. So there is a positive sodium ion droplets present in the surface of the water, and these ions basically repels each other, as we know that positive ion repels each other. So they goes on the different directions. So this behaves very like a negative surface tension, and the surface tension of the sodium increases area rapidly, forming a Spencer porcupine-like shape as the fingers of the sodium, and there is a big explosion. There are some main points in this reaction. First is this reaction is exothermic reaction. Just because when sodium gives out its extra electron to the water to form itself a octate noble gas electronic configuration. Now what is it? Octet rule states that the chemical species is more stable when all of its atoms have achieved a noble gas electron configuration. This means here you can see when Na neutral gives out its extra electron, it form a positive ion. This means now this ion have 8 electrons into their shells. So there's in the last shell they have are 8 electron, that is a much more stable than the normal sodium element. So now the positive ion of sodium is much more stable than the sodium its neutral element. Second main point is water does not accept electron readily, and there's a big explosion. So friends, the basic idea of this reaction is when sodium gives out its extra electron readily to any other compound, here it's water, then is a big energy which is released, and there's a big explosion onto the surface of water. Friends, let's understand now the difference between the sodium element when dissolved in water gives a big explosion, but sodium compound, let's take an example of NaCl, sodium chloride compound, when react with water, dissolve it completely and gives a good taste. So we have when any element in the neutral state added to water give a explosion, whereas compound of sodium called sodium chloride when added to water dissolves completely. What happens? Well, moving towards with the same, when the sodium element is in the neutral state, it have 11 proton and 11 electron with the electronic configuration 281. And this electron is basically when is given out to attain octet rule or say noble gas electronic configuration. So this means when sodium in the neutral state element gives out its extra outermost electron, that is valence electron, forms a stable positive ion with a +1 cation, and this electron is basically given out with water and gives a big explosion, wherein the Na positive is itself into its stable state with 11 proton and 10 electron. The electronic configuration will be 2,8. This means this is already into its noble gas electronic configuration, wherein we take this chlorine as with the atomic number 17, which have 17 protons and 17 electrons, and the electronic configuration will be 287. So this means, friends, in this reaction, chlorine has an electronic configuration of 287, where if to make the chlorine more stable, it needs one more electron to form a noble gas electronic configuration or into its stable state. So what will happen in this kind of compound? As a neutral compound, sodium chloride results of electron transfer from sodium atom to chlorine atom, resulting in the formation of stable cation and an anion which held together by electrostatic attraction. So this is basically a stable compound. This is I gave, I accept, creating a electrostatic attraction or say ionic bond. So this compound when reacts with water, what happens? When NaCl is attracted towards the oxygen side of the water molecule, while the chlorine negative side is attracted towards the hydrogen side of the water molecule, gives out NaOH and HCl. Well, thus we say that the salt is dissolved. Well, salt will just dissolve in water and no chemical reaction occurs because water molecule is very polar and it pulls out the sodium and chlorine ions, and when it's fully dissolved in water, the salt solution will full of sodium and chlorine ions. That's it. So this is basically a non-explosive reaction, and when compared to the sodium element, combining with the water gives a big explosion just to form into its stable noble gas electronic configuration. So friends, now you can compare the both of the reaction. The previous one, which is the sodium reacting with water, gives an explosion. So this preparation is not actually preferred for the preparation of hydrogen. So this was the session to see how sodium helps in the preparation of hydrogen gas. But yes, it is not preferred just because it's a very explosive and violent reaction. So moving towards the main menu, in the next session we shall discuss how calcium reacts into the cold water to form or generate hydrogen gas. So let's meet in the next session with calcium. Thank you for watching Edupedia World Videos.